Hi there, I'm Daniel Markham. I wrote the domain model for domain modeling, and let's talk about learning and tessellations and fractals and all sorts of cool stuff. Gonna make it quick. Okay, so I'm trying to get on my gear here. Next scene. Ooh, this is like a scene. Cool. All right. Okay, so a bunch of stuff kind of came together over the last week or so. It's a good essay Michael Feathers wrote about components and how teams build components, and many times the components sort of get lost, I guess, in the process. They become part of a library instead of something managed and owned by the team. There was the thing I did last week on sort of the ladder of learning. All this stuff is kind of related, and let me tie it in for you. If I can. This button is supposed to do this. Dang it. Yes, it does this now. Okay. All right. So start off with a typical program. Yes, this is trivial. Remember here, the goal is to try to come up with the most trivial, simple sounding thing that we can use in multiple places. This is the goal of modeling, right? So when I build a model, I'm not trying to make, like the battleship Potemkin or one of those big Star Destroyers in Star Wars. That's a whole different kind of thing. When I build a model, I'm trying to make the very simplest thing I can possibly make to sort of intellectually get a grasp on what's going on. And that's what we're going to do here, talking about all these 17 different concepts. All models are wrong. Some are useful. Okay, so here's Hello World, and it's quite exciting. I did this in F#. The languages don't matter, but if you like F#, here you go. So user comes in and says, Daniel, I'd like you to write Hello World. Daniel sits down, there's Hello World. It's an amazing thing of beauty. And then the user says, no, wait a minute. No, I actually want you to say Hello Daniel. Okay, Daniel goes back up. Changes world to Daniel. Hits the button again. User says, oh yeah, I guess that's... But wait a minute. I also want to say hello to Tony. So I'm starting to think maybe this could be some sort of bill by the hour gig here. I go back up, add in hello Tony, I hit the button, look at the user as if, hey, we're going to be okay with this or not. And then I notice something. Wait a minute. We got hello Daniel, hello Tony. We've got hello mentioned twice. And I learned a long time ago that's dry. Don't repeat yourself principle. Dang, that doesn't look right to me. The user's still sort of sitting there staring off into space, doing whatever users do. So I go, wait a minute, no, hang on. What I need is like a hello person, maybe function. And I like console write line better than printf. So I use console write line hello person. And I add that and say, well, that looks okay to me. And then I notice, well, I'm not actually calling that. And so right here. Yes, I call the hello person, and with both these things, and this is good. I'm happy. He's happy. We're all happy. And then he, being the user, says, really, there's Steve. I forgot about Steve. I want to say hello to Steve as well. So I do some stuff, and I hit the button again. Hello, Daniel. Hello, Tony. Hello, Steve. He seems to be happy. I'm happy. Maybe I can go home, maybe it's beer time. I don't know. And then I look, and I start noticing, wait a minute, hang on. Hello person, wait, I'm repeating that hello person token now. I really need like a hello people thing, right? And so then I write hello people, and it takes a people list, and for each item in the list, it does the same thing, and it's going to do it better than hello person. And it makes me feel like that collection of symbols on line 4 and 5 are more betterer than the other one. And so then I have to, of course, pull it up and such that it calls and does the work for the entire list. So now I am happy. So I continue maybe back and forth, and maybe I go away, come back after lunch, I look at it again, and I can even collapse it further. The more I look, one of the wonderful things about F# is the more you look at it, the more it kind of collapses. And so here we have the same code in like 2 lines of code, and who knows, it may collapse down like a comma or something. It's cool stuff, very amazing. So what happened here? Okay, aside from you guys spending some time listening to how to do Hello World again, something very, very, very interesting happened, which I don't think we think about enough. And this is why I'm using the trivial example. Each piece of that program is a piece of structure, right? The token Hello People versus Hello World, versus what was Hello People versus Hello Person, the various pieces of this code. Every little thing I type in is a piece of structure, and those pieces of structure all exist to make what? One would think to make the user happy. He wanted Hello World, he wanted this, he wanted that, and then we type things in and he was happy. But that's not exactly true. Partially to make him happy, and partially to satisfy rules I bring to the table by going, no, wait a minute, in this environment, I'm not comfortable looking at this unless it looks like this over here, because in the past I found that evil witch doctors will come and assault me in the middle of the night if it looks this way. So he brings the behavior to the table, and I bring, let's call them non-functional supplementals. I bring supplementals to the table. These are rules that should always be true, right? You should never repeat yourself. And I bring these rules and I apply them to whatever behavior he wants from the system, and together, this bits of structure come together, right? Is this architecture? Yeah, kind of, sort of, right? And it's like this. I'm talking about structure in the sense of tokens of code, right? And then these supplementals I bring actually may blow out those structures into smaller tokens. We saw that with the refactoring. We saw that with the renaming. And those structures come together in units. They could be functions, classes, parent classes, and then all of those structures and units together form these patterns we call architecture. And the architecture can be client-server, sort of Xcode, iOS deployment, bunch of cool books on architecture, and that's speaking of technical architecture. But from my standpoint, even from a technical architecture standpoint, everything in that architecture is there because of a test. Now, we may have never mentioned the test. The test may just be, ooh, I like variables that start with the letter C. That's perfectly fine. Programmers bring implicit tests to the table all the time. But you don't type something on the machine unless there's something in your head that says, ooh, the thing I perceived is different than the thing I want it to be, and so I will do this to make it the way I want it, right? And so between the behaviors and the supplementals, we end up with some sort of architecture. And supplementals can get quite involved. They can use this framework all the time, but they can be fairly simple, like just do everything in 2 lines or less of bash or something. I don't know. Actually, that would probably be very, very hard, but you get what I'm saying, right? The supplementals itself and the nature of the code may be, you can have a lot of supplementals for a very small amount of code and a very small amount of supplementals for a large amount of code. The two are not directly related. And most supplementals are not stated. That doesn't mean they don't exist. It just means they're not stated. Okay, so behavior, supplementals, structure. Structure rolls up into various forms that are persistent. We see these across various places. Those forms are architectures. To say this in a different way for you Agile dudes, you have a user story. And a user story is just when somebody picks a behavior. I want to say hello, Steve. And then somebody else picks some supplementals, or maybe the same person. Well, we have to do this in C#, and every variable has to start with the name pickle. You combine those two to make a testable chunk of value. You create the tests. You do the work to make the test pass. And bada boom, bada bing, the user story comes at the bottom as a piece of value. Those tests, while it would be wonderful if everything were an executable test, many, many times they cannot be. Sometimes the test is, do the users like looking at the screen or not? You can't write an executable test for that, but that's a very legitimate test. So don't confuse with create the test and do the work to make the test pass to be a programming only exercise. Okay, it is critically important when you're doing mutable OO that it is most of it's testable for each piece of OO work you do, because you have no idea what the impact on the rest of the system is going to be. It's different when you're doing UI, or maybe you're in a different domain. Maybe you're creating a business. Sometimes you don't even have a computer. These things still apply, which gets us to the next thing. Looking at Mr. Feather's wonderful essay yesterday, he goes down this path of talking about how a programming team can get together, create a reusable piece of work, a component, to do various piece of value. And over time, they split it off in its own little thing, and maybe they share it with another team, and maybe this third team comes out and just sort of takes a copy of the code and doesn't change it, and these other two teams are working on their own, and you get this drift that happens, and it happens to everybody. Everybody's seen it. And his point at the end, among many points actually, is that the area of code that you work for months in is something you understand deeply. I read this and I went, Michael, dude, this is what I've been talking about for a while with InfoOps 3. We do analysis as a team, as a social unit, and that social unit learns a business domain and comes up with a set of rules of how it applies that domain through its own supplementals to some sort of executable piece of code. Maybe we write components like this, they write them that way. We have our own things we come up with as we understand the problem. Coming in cold to this a year or two later, you may understand the code, but not understand the code, right? I can tell you what the code is doing. I can't tell you why it's doing it or what the purpose is. And that turns out to be quite important. Would you use a boxed variables in a large array if you knew that the reason it was doing it is to process something very quickly? Probably not. But if you don't know, how would you ever figure it out? Okay, here I have a slide with nothing on it, and I hope that serves as a lesson to you. So this gets you back to the thing I was talking about last week, and the two are related quite a bit. There is a stream of activity here we've talked about when we did Hello World that Michael's also talking about. And this stream of activity could probably best be called learning, right? On the left, and I've got this at the amoeba kind of primitive mind level, at the left, I perceive qualities about something. I don't perceive the thing itself. That screen doesn't have the thing on it I want to see. That doesn't mean I understand what the screen is or how it works. It means I want it to say Steve, and it doesn't. We form mind pictures of how we want things to be or what things are. That's in the middle. And then through the qualities in the mind pictures, we apply rules on the right that we think are always going to be true. And I call that religion. It's probably, I'm going to change that. But the idea being that, if a baby cries, the light comes on, and the baby's mind, crying made the light come on. This is just the way all of our brains work. We work by processing inputs into sort of random patterns we make into rules, supplementals, right? This is the learning path. And you might say, well, gee, Daniel, what does this have to do with programming or coding units or any of the other stuff? Well, the thing is, it doesn't exist at just this level. If it did, we'd probably be talking about some sort of artificial intelligence thing, and we could blow out how these first two bubbles and kind of go into some neural network stuff, all kinds of cool stuff, which I'm probably going to go into, but we're not. First, we have to look sort of lay of the land stuff, and that takes us to, where are we going? Somewhere else. Hang on. Okay, so this is what happens when you don't save your PowerPoint on the other computer. So anyway, we have this one layer of learning that animalistic, primitive, unconscious, maybe if you like that, happens to everything that can perceive things, and that's kind of sort of what we've been talking about so far. And a lot of times we model AI as if this were the only level we were talking about. And I think this is kind of where we've screwed up in a lot of ways, because it's really not the long and short of it. Okay, so there are actually 4 levels. And each level is important. Each level sort of works its own way, but they're all that same process of I see, perceive something, I want new behavior, I have supplementals, and here's a test that passes or doesn't pass. We have the personal subjective, which your dog can probably do. And then we have the abstract, which is humans do this. Your dog probably also does this to some degree, and that is reasoning about things in the abstract. I sense some qualities about this box here. I feel it. I see a shape. I'm guessing this is something I call a phone. That's an abstract object. There are bazillion phones in the world. This is not a pure phone. It's just my abstraction of a phone. And that I understand that phones follow these rules in the right-hand column. Each of us has our own abstractions about concepts we encounter in life based on our life experiences with those things. That's kind of a powerful thing that I think most of us don't understand. That is a pre-language thing. So people who can't speak or hear language can also have abstractions about things. I don't know how they do it. I imagine they're done using picture objects. I don't know. I know dogs can't speak, and I think dogs can abstract about various things. So we abstract things on our own, and we reason from abstraction. That way we don't have to figure out what each new phone is. I don't have to discover this phone in some new way. I know it makes calls, I know it takes pictures than the phone I had last year. So that's the first two levels. We have our subjective experience, we abstract about things and reason about them, and then we have conversational learning. And language is what takes us from our internal abstractions to sort of a group understanding of things. And that's at the third level from the bottom. And it's the same thing. We have qualities, we have objects, and we have supplemental rules we think are always true. So we use language to sort of bind together various people's ideas, their internal abstractions of various things, into something that sounds as if it's the same abstraction for all of us. It never is, which is really cool. So you and I could talk about phones for quite some time, and we would be very happy that we agreed what a phone was and everything. I can guarantee you that tomorrow I would pick up a phone and say, hey, look, I can make notes on this phone. And you would go, hey, I didn't know you could make notes on a phone. And your abstraction of phone would change. We cannot synchronize minds as if there were some sort of Dropbox folder that I screwed up with this thing here. It doesn't work that way. Language, in fact, is designed not to do that. So the goal of language, if you really think about it, it's evolved to use the sort of smallest number of spoken sort of sounds and grunts and sort of social contexts to communicate just enough information that the group or clan can sort of move forward whatever the next activity is. Language is not an exhaustive definition of anything. It never was meant to be that. All language is spoken. Written language sort of throws a whole new kind of curveball into stuff. So language is how groups of people sort of compare abstractions and come up with sort of useful, I guess, mezzanine languages that they can use to do other things with. All of this happens completely naturally. We never really realized it until we started picking pieces apart. Why did I know that we could talk about this phone all day and tomorrow we would have a different thing that would not match up? Because, dang it, I'm a programmer and I have spent all day talking about various concepts with people and we've completely agreed on it. And the next day I go to program these concepts and we don't match up. So I've done this a million times. And so that conversational thing, then once we map up to the real world, which I would consider sort of a mathematical sort of categories and transforms world, we start finding that the symbols aren't consistent, that the behavior over here doesn't match the behavior over there. And then suddenly, once we start applying math to language, it becomes programming, or it becomes sort of a formalized version of what we're trying to define. How does this play back into the component model? Well, what happens when a team gets together to build a component as part of a larger project is that team or those group of coders, however those coders work together, are a conversational unit that's doing analysis and learning about this particular problem and come up with all their own supplementals that they want. Oh, we're going to have components like this. We're going to use getters and setters. We're going to use dependency injection. There's a bazillion technical and non-technical things. Most of these things are never spoken, just like each other level. And most of these things, the programmers have different ideas, even if they think they don't, because that's just the way language works, right? And so once they start actually coding it, whatever differences they may have had suddenly becomes a piece of mathematical rigor, right? Because it has to be consistent to some degree, unless you're using Visual Basic, in which case nothing matters. But so when you have different groups of people, or you start splitting the groups up, or the code goes away and comes back, and the people don't remember it, or the conversation has changed about those abstract objects in each person's mind, suddenly you've got a piece of math that may be self-consistent, but doesn't relate as directly to the meaning everybody has inside their minds like it did when they coded it. Now, this has a lot of very interesting consequences. It, it may be that executable tests are the things we should be sharing instead of code. So it may be that, this is going to sound crazy, but it may be that really what we should be creating is componentized scalable tests. And those tests can be shared and moved places and moved around because there's no interpretation. They run or they don't run. And then each team or each person who has to solve a problem or improve on the problem has to figure it out on their own how to make those tests fast. But we don't share code. Sharing code may be a very, very bad thing to do because code, by definition, is the result of some sort of analysis process that is a social construct based on whoever people were that actually analyzed the problem. And you're probably wondering how does sort of open source software work with this? I imagine because there's probably a lot of tests involved with it. And those tests either drive out conversations around the analysis or just determine by fiat what these things are going to mean. So in some ways, if you start with the test, which is kind of what I'm suggesting, you start at the top level and then you have to work your way down. And so instead of the team learning what the components are and coming up with their own sort of standards, instead you're sort of saying this must happen no matter what in this way, and then the teams have to figure out really what you meant and why you meant it that way. That may be a much better conversation than the way we're doing it currently. This also brings up a lot of problems we're doing with AI. I think what AI is trying to do is do this learning at the bottom level, where we're doing sort of a lot of Bayesian stuff, and which Bayesian kind of maps enough that it looks like it might work. But then we're sort of applying this Bayesian stuff at the real level. So we're skipping the whole abstraction level, we're skipping the whole conversational level, and we're just saying, hey, if every time I type in I want a dog, if 99% of the time people say I want a dog biscuit, when the guy types in I want a dog, we're going to put biscuit there. That's probably going to work 99% of the time. It sort of takes out any sort of learning that goes around about what a dog is, what a biscuit is, how people feel about dogs. This is the problem when you do computerized recommendation, right? So if I recommend this, what's the best restaurant for me? And I push a button and it tells me the best restaurant. I'm sort of eliminating this entire level of stuff. I'm just saying I want to go to a restaurant, and it says turn right. Matter of fact, I don't even have to say I want to go to a restaurant. At some point, it would just find the stimulus that I'm hungry and give me the instruction what to do. And all of this whole learning thing would just go away, and I would just be following the computer around, right? But there's a lot to be had with the abstraction level. If we want to find the best restaurant, we probably should have a conversation with a bunch of people about what's your idea of a good restaurant and why, right? And there's this whole journey about I like the ambiance, I like French food. Those are the things you learn when you're hungry and want a good restaurant. If you push a button or the computer tells you, knows you're hungry to go eat, turn right, you're no longer learning. As a matter of fact, you're probably sort of working at that amoeba level. So if we're thinking AI would only work at the bottom level and just somehow ignore the other parts, we're going to end up with some really dumb people. So anyway, this is components. To get into fractals of tessellation, I think the tessellation comes in with orthogonal requirements that are mutually orthogonal. And then the fractal part is that the general same part sort of chain of learning that we looked at in the code happens across the stack. Once again, nobody's trying to build a model of everything. I'm trying to come up with the minimum number of symbols necessary, sort of map what I understand so far. If I can get 89% of it, then we can sort of get traction on a bunch of other problems, like how do organizations learn? How do I bring new people up to speed that haven't been on the team? What are some problems with deep neural net learning? How might we overcome them? A bunch of other really, really important stuff, all based on having some model of learning that scales from amoeba up to like the universe. I'm Daniel Markham, and I will see you on the internet. Feels like I get this thing working. I feel like I bought this from Mr. Haney.